Hello, this is a video on factoring polynomials. I've done some other videos on factoring polynomials, but here what I want to do is try to bring everything together in one place fairly quickly. So here's sort of a general strategy to go with in factoring polynomials. The first thing is you want to factor out any GCF that you may have. Okay, so that's the number one thing. Then you want to check to see if the first and last terms are perfect squares. If they are, you want to remember that if you have a plus b times a minus b, it's going to end up looking like this. You want to remember if you have a minus b squared, it's going to be a squared minus 2ab plus b squared. So you're looking for those perfect squares on both ends. What I do is look at perfect squares on both ends and then check to see if the middle is like this term, okay? And you can FOIL it quickly and see if that's true. And then a plus b factors to this. Remember that. Now, those are the easy ones, really. Now, if we get it and we have a coefficient on the first term as 1, those are pretty easy also. We do a guess and check where we know that the sum is the middle coefficient, whatever that is, and then the product is what the end term is. Okay, so we'll go through some of those examples also. Now, the toughest ones are where the coefficient of the first term is not equal to 1. It's more than 1 or negative. If it's negative, actually don't do one of those here, but you will want to go through and make that positive. I'll show you in class how to do that. But we could use a guess and check method, which sometimes works, but actually you can spend a lot of time with that. So the grouping technique I showed you is often a better way to deal with those, or a more certain way to deal with those. And then it's always good to remember that sometimes polynomials can't be factored. I'll give you a couple examples of those. And then sometimes there's many layers of factoring. I'll show you some examples of those also. So let me begin here. And so on the first one I'm going to show you, it is right here. It's 7y to the fourth minus 21y to the third. This shows us the first general principle of factoring out any GCF. You may have to factor beyond that in many problems, but we'll start by that. So here we can factor out a 7y to the third actually here. So I can go 7y to the third is the GCF, and then I look at how do I get from 7y to the third back to these two terms here is what I'm looking at. So 7y to the third must be times y, and then this is to get from 7y to the third to 21y to the third, we're going to go minus 3, okay? So now we have completely factored that because we can't factor y to the third anymore. Okay, so that's the first example. Here's one that I'm looking at this and it jumps out to me right away that I have perfect squares. I have 25x squared and 49. So what I'm going to do, as a matter of fact, there is no middle term. This is subtraction. This is going to be a situation where it's like a plus b times a minus b is equal to a squared minus b squared. This is an a squared minus b squared problem. So I'm going to take the square roots of both these, and it's just going to be 5x minus 7, square root of this, square root of this, and then 5x plus 7. Okay? And that's that completely factored. Okay, my next one I'm going to have here, I look at this again and you'll see it's a similar problem, but I have, perfect squares, but it has a middle term now and it's positive. So I'm going to see, is this a situation, is it 5x, because that's square root of this, plus square root of this is 7, times squared, but I'm going to put it out here so I can FOIL it, 7, and I'm going to see. I know these are going to be right, so it's mainly just checking this middle term here. And this middle term is going to be 7 times 5 is 35x. And 7 times 5 is 35x. Ah, it's right. That gives us 70x. So the solution here is, not the solution, but the factoring here is 5x plus 7 squared. Okay? Another one that looks just about like that is going to be basically the same thing, but the middle term is going to be a subtraction. Okay? So I know this is going to work because I just did a similar one, but if we were looking at this again, I would say, okay, perfect square. So 5x, and this is a minus, so this needs to be minus. Square root of 49 is 7, so I go this, and it would be squared, but I'm going to actually put it here so I can FOIL it. We know this is going to give us 25x squared. We know this is going to be plus 49. Is this going to be minus 70? And minus 35x plus minus 35x is minus 70. So this indeed is equal to 5x minus 7 squared. Okay? I'm going on to the next type of problem. And the next type of problem is that one where no perfect squares, but the coefficient here is 1. In other words, there is no coefficient, so it could be a 1, right? And so that's the type that are pretty easy to do. I need a, sometimes people do like this. They want a product, so they could put up product here, a product of this, negative 14, in a sum of negative 5. So I'm going to go through and make a list here. So I could say, okay, well, I could have 1 and 7, 1 and 14. I could have 2 and 7. One of these is going to have to be negative, one is positive. I could have, that's about it. Well, I got the 2 and 7. Could I make negative 5? Well, if this was a negative 7 here, 2 times negative 7 is equal to negative 14. But 2 plus negative 7 is equal to negative 5. That's what I want. So I know this one is going to be x minus, and let's see, we said a positive 2. So we're going to have x minus 7, x plus 2. And I'm going to FOIL this to check it. So I'm going to get x squared. I'm going to get negative 14. And then the crucial middle term is I'm going to have negative 7x plus 2x is a negative 5x. And so that is it. So I got it. Okay, the hardest type of problem is, well, you can have a lot of hard problems because they can give you really big numbers and combine a lot of different things. But here's a pretty easy example of a hard type of problem. And that is where we have a coefficient of greater than 1 or less than 1. So on this one, what I'm going to do first here is I could do a guess and check. Let's try a guess and check. A guess and check would be, well, I know to get a minus here, one of these is going to have to be positive, one is going to have to be a negative. And so that's going to help me there. So as far as possibilities here, as I'm going here, it could be 1 and 8, or 2 and 4. 2 and 4 is looking pretty good to me. And then I'm going to have something x here and something x here, okay? So one of these could be 1 and 6 or 2 and 3. Let's play around a little bit. Let's say we have this is 2x and this is 3x. And then let's say this is 2 and this is 4, and let's see how we are. So this is 6x squared. This is minus 8. This is plus 6x, or 6x, and this is minus 8x. We found it the first try. Not a very good example because usually you don't find it the first try. But we found it the first try. So our answer is, the factoring is 2x plus 2, 3x minus 4. So, but that's not, because there's not a whole lot of different possibilities here. That's not a bad one to do guess and check. But I'm going to do that same one in a different way. And so I'm going to put 6x squared minus 2x minus 8. And I'm going to do that by the grouping method. I'm going to fold my paper here to make it a little easier here. Okay, so pretend you've never seen that problem before. Now we're going to do it by the grouping method. You know, and actually back here, this is a teachable moment, teachers call this. Actually, I didn't completely factor this before. I should have factored out the GCF first, and I didn't do that. But even if I don't do that, I can see that I can factor it out here. So actually I have 2 times x plus 1, because I can factor that out, times 3x minus 4. So there's a teachable moment for you. Okay? I'm going to now do the same problem, but I'm going to be using the grouping method. So let me go ahead and do that. And I'm going to, so the problem was 6x squared minus 2x minus 8. Well, now that I've done it already, I know that a good thing to do is to first factor out the GCF, and that should make this one pretty easy. But the GCF here is, I can factor out a 2, so this is 2 times 3x squared minus x minus 4. Okay? I'm going to do the grouping method. This would be an easy one to do guess and check on now, but I'm going to do the grouping method nevertheless. And this is going to be an interesting one to do the grouping method on. So what I could do is I could say, well, I'm going to take this part here, and I want something whose product is 3 times 4 here, or 3 times negative 4. 3 times negative 4, so I want a product of negative 12. And I want a sum of negative 1. So I could say 1 and 12 isn't going to do it, and we know 1's going to have to be positive and 1 negative. Or I can say 2 and 6, that's not going to do it. I could say 3 and 4, that is going to do it, especially if this is negative and this is positive. So this is it. Now, this is what I do with it. Right now, we're going to ignore that 2. I could put it in, but I'm just going to focus in on this right now. So I'm going to go 3x squared, and then I'm going to break this up here. So I'm going to say minus, I'm going to say plus 3, and then I'm going to say 3x, I should say, of course. Yeah, actually, I'm going to do it a little bit different way. This will be a little easier. I'd like getting my minus in this spot. So I'm going to say 3x minus 4x, and then plus 3x minus 4. Now, can I do that? Certainly I can do that, because the only thing I've done is substituted minus 4x plus 3x for minus x. So that's fine. Well, what I'm going to do is group this and group this. Okay? And so what I'm going to end up with is I can factor out an x here, and then I get 3x minus 4. And then this one, actually I can't factor out anything here. but I can put 1 times this. If I can factor anything out, I do that. But if I can't, it's just 1 times 3x minus 4. And so this one's, what I can do now is with distributive property, this is going to be 3x minus 4, which I can factor out, times x plus 1. Okay? And then, so that's this part up here. But then I'm going to remember I had this 2 outside, and I get 2 times 3x minus 4 times x plus 1. Okay? And if you remember back to what I had before, we get the same thing. So here's what I had before, and we've ended up with the same thing, but a different method, the grouping method now. Okay? Now we're going to go to a couple here that we can't really factor. Because I'm going to look at this, I'm going to say, oh, perfect squares, but for this to be a minus b, a plus b situation, this has to be negative. Nothing I can factor out, so this is not factorable. Hopefully I'm spelling factorable correctly. Here's another one. Here we have x squared plus 3x plus 1. Well, we know the product needs to be 1, in the sum 3. But I can't think of anything where the product is 1 and the sum is 3. Okay? 1 times 1, negative 1 times 1, but neither of those products is equal to 3. So again, this is not factorable either. Okay. One other type of problem, and this just shows you that problems can take, they can have many different layers to them. And I haven't really shown you many examples of this, but here's one type of example. First of all, I look at this, and I know I can factor out a 5. So I go 5 times t to the 8th minus 1. Okay, you think I'm done? No, I'm not done. These happen to be perfect squares. So this is 5 times t to the 4th plus 1 times t to the 4th minus 1. Okay, good. I'm not done yet, though. Because, well, this can't be factored anymore, and 5 can't be factored anymore. This can, because this is a difference of squares. So let's get some equal signs in here. And I get 5 times t to the 4th plus 1, just copying what I did. But this is now t squared minus, well, I'll put plus 1 times t squared minus 1. Pretty cool. Okay, well, I must be done now? No, because this is a difference of squares also. So now I'm going to copy down a lot of what I already have. And t squared plus 1, t squared, okay, so this is what I can factor out more here. Let me get a better eraser. And I'm going to get, this is going to be t plus 1 times t minus 1. Okay? T is not a perfect square, so I'm done now. Okay? And so this is my whole answer to this one. So as you can see, they can get very long. So again, I hope that overview of the different things was helpful. Again, what I want you to remember is, remember first factor out in GCF. Look at whether the A and B terms are perfect squares. If so, then you make it this type of situation. If the coefficient of the first term, the A term, is 1, then you want to, you need a sum, who's the middle coefficient, and the product is the last term. And if you get a coefficient of the first term that's not equal to 1, is greater than 1, then you could try guess and check if there's not too many factors. If not, use the grouping technique which we've talked about, and you should practice that a lot. It's really a powerful technique, although there is more work on the front end of remembering how to do that techniques. Finally, remember that some polynomials can't be factored, and remember that sometimes there's many layers of this, so be sure that you have completely factored it. So with that, we'll end this video.